So this is so each of you should have gotten a quiz review guide for sections 4.1 and 4.2. I want to get through this so that you have it because I've built it specifically around what you're going to see on the quiz. But then hopefully we'll have a little bit of time at the end of class to go over some of the word problems because there are inequality word problems on the quiz. And there's a couple in the book in our homework assignment that are very similar. So I want to do those as well. But the first part of the sheet is a matching where you're matching phrases that mean the same thing. So you have different ways of saying greater than, less than, because you have at most, at least, exceeds, as little as, that kind of thing. So I wanted to look at which one, A, B, or C, matches is at most and what it means. So if I said is at most, that's the same as saying what is less, C, does not exceed is yes. So that means does not exceed. So is at most means that your number or your variable is less than or equal to some value, but it can't be more than that value. Same thing with does not exceed. That means it means less than or equal to. So it can be less than and it can equal the value, but it cannot be any more. It cannot exceed it, right? So number 2 is not greater than or equal to. Therefore, it must be what? Is less than. Right, that's that negation. So is not greater than or equal to, has that line through it, it's negated, is the same thing as less than. Right, those mean the same thing. So recognizing that is going to be very important. And the reason this is on this is because we have it on our quiz too. We need to be able to interpret these phrases and what they mean in terms of inequalities. All right, number 3 is not less than. Means the same thing as what? Is at least. So it means it can't be less than, so it must be more than, but that also means it is at least. Oh, that's awful. Try that again. L-E-A-S-T. What symbol is that? If X is at least 8.
Greater than or equal to.
Yes, which is hard. It's the opposite of what you kind of want it to be. But when we say it's at least 8, that means it can be 8, but then that's the lowest value it can have. So it must be greater than or equal to, which is the same thing. It's not less than, so it must be more than or equal to, but it cannot be less than. Okay, last one. Is not as much as. Is equal to what phrase? So is not as much as means does not exceed.
It means is less than.
Yeah. See, does not exceed means it can equal, but it can't be more than. Not as much as or is less than means if it equals, it doesn't work. So this is less than, not less than equal to. Okay. Those are in a chart along with some, I think the first group of exercises for section 4.1. So if this part is really confusing to you, I would look at those and write them down, match them with the symbol they go with, just to get a little bit of practice of being able to interpret those phrases. All right, part 2 means that we need to check whether each value given is a solution to the inequality. So they give you a solution, they give you an inequality, and they're asking you, is this solution true? Does it make sense? So if number 5, we have the number -3, and we're asked to pretty much just plug that into the expression x squared plus 4 is greater than or equal to 12. And I forgot the 4. There we go. Okay. So anybody want to volunteer for this one? All right, Andrew, let's do it.
Okay, so you plug in the -3 where the x is.
Like this?
Yeah. Yeah.
Yeah?
Yeah.
Do you?
Yeah.
It's got to be in parentheses. Here's the difference. -3 squared with no parentheses. Sort of a trick. I sort of set you up, but at the same time, I wanted to make sure you saw the difference. -3 squared is a -9. -3 squared in parentheses is -3 times -3, and a negative times a negative is a positive. So you see, you end up with different answers. So anytime you plug in a value for a variable, remember there's an understood parentheses. Okay, so here it is. We just need to make sure it's in parentheses. That way, as I've just worked out, you have -3 times -3 is.
Oh, 9. I've done that anyways. That's the thing. And we subtract it.
Okay,
So that's out.
so 9, well, we plugged in a value. What's 9 plus 4?
Wait, 13.
I know, it's the end of the day on a Friday. We can make it. We can make it. Now, is 13 greater than 12? So our answer for number 5 is yes or true. It makes it a true statement. The inequality is true with the value -3 plugged in there. Okay, so here would be the difference. Excuse me. And this is not on your review sheet. I just want to show you. If I had that equation as -x squared plus 4 is greater than 12, then you would need to be able, and I told you that to plug in the value of -3 for x, then you would need to know that this was -3 squared. And so your answer actually would become -9, because the negative is outside the variable. So you would need to treat it separate from the number being squared. So that's sort of where you have to be really careful and just understand that a number inside of parentheses, or a number being plugged into a variable, you need to carry the sign with it, like in this instance with the -3. All right, so let's look at number 6. So number 6, what just say 6? Number 6 gave us 0 as a solution for -6 plus a to the 4th is less than -2. So yeah, I mean, it's true already.
That's 0 with the exponent, it's pretty obvious.
So it's 0 to the power of 4. Yeah. Right. So is -6 less than -2? Yes. So again, this is just an example to remind you that a larger value that's negative or a larger number that's negative has a smaller value than a smaller negative number. So -6 actually is smaller than -2. Okay, number 7. Is 3 a solution for x squared plus 4 is less than 12. What's 3 squared plus 4, which is the same solution as -3 squared because you're squaring it. And so is 13 less than 12? This one's no. It's the same as number 5, except I reversed the inequality. All right, so 13 is less than 12, so no. All right, last one. Is -2 a viable solution for a to the power 4 minus 6 is greater than -2? I sort of kept this easy because on the quiz, they're really kind of this easy. You just need to be able to recognize that if you have an even number for your exponent, then no matter if your value for the variable is negative or positive, you're going to end up with a positive answer. Because this is negative times a negative times a negative times a negative, which is a positive. So as long as you have an even exponent, you will have a positive answer. Okay, -6. So what's 2 times 2 times 2 times 2? Okay, I'll let you think. 2 times 2 times 2
16, -16, sorry. -16.
is it -16?
Okay, so -2 times -4. -2 times -2. Sorry.
Is a
It's positive.
is a positive 4. And then a positive 4 times a -2
It's -8
times a -2. There you go. It's okay, deep breaths. Breaths. Like I can't talk either. So -16 minus 6 is, which is, yeah, so that's a yes. Well, yeah, we're gonna get through this and then we're gonna do like 2 problems in our book. I like these word problems. I'll make a nice, neat notes as we go along. I detected sarcasm.
Wow. As long as I have notes for one of them.
It is my first language. All right, number 9. Number 9, so 9, 10, and 11, we need to solve for the inequality, and then we need to graph. So x plus 18 is less than or equal to 7. All right. What 18 from both sides? Right. We have to isolate our variables, so we subtract 18 from both sides. Do we need to do anything with our inequality? Okay. But it's -18.
You're not multiplying and or dividing.
Right, we're just subtracting, so don't worry about it.
It's less than or equal to -11.
Yes. So x must be less than or equal to -11. So let's graph it. Keep it simple. Sure.
Okay, started -11.
Somewhere in the middle, right?
By 24 here.
You are a terrible person. Count it, take marks by 24s. All right. So we,
Put the little dot at 11 and it's close because it's 42
yes.
and it is going to the left.
Yes, so it's a closed dot because -11 is included as a solution. You got this. To the left, to the left. Okay. All right.
Happens sometimes.
It's totally by accident, like a jerk reaction.
Yeah.
Number 10, -5 x is greater than 25. All right, Eden, what do we need to do here? By -5. Now, in this case, do we do anything to our equality symbol? Because we're dividing by a negative number. So we have to do what? Yes. So we reverse it, flip it. I can show you the proof for it if you want. Okay, but I think today is probably not the day for that. All right, and our answer is going to be negative or positive. It's going to be -5. Yes. So x must be less than -5. So if you're not sure if you were supposed to flip it or not, pick a number less than -5 and then plug it into the -5 x greater than 25. If you get a correct answer, you did it right. If you don't, you need to flip your inequality. Okay. Number 11. I gave this is yours. Oh yeah, we did forget the graphing part. Sorry. My bad. All right, so my graph. Start with a -5 in the middle. Okay. So where do I start my graph? And is it open or closed? Right. So you don't fill it. Yes, so it's not closed. So you keep it as an open circle. So it should look like a bullseye. And do we graph down less than 5 or greater than 5? Yes. So we go to the left. Okay. And there's our graph. Yes, thank you. Okay. Number 11, Gabe. Y divided by 8 is greater than or equal to -3. Multiply by what? Okay. So we're left with y. And do we do anything with our inequality symbol? No, because our 8 is not negative. The -3 is negative, but that's not what we're dividing by, so we don't worry about it. Yes. Okay, you're right. -3 times 8. 24. Yeah.
Negative.
There we go. -24. A lot of negatives in these examples. All right, number line. -24. I'm gonna go this way first. Don't forget, your numbers go backwards when they're negative. All right, so we start our graph closed. And then we go y must be must be greater than and equal to or less than and equal to. Right, so we go this way. I know actually doing it and then trying to explain it are two different things, but yeah, that's correct. All right, so number 12. All right, so number 12 says find all the numbers such that the sum of the number and twice its opposite is at most 15. So sum means addition. So we've got some addition in here somewhere. Sum of the number, what variable do you want to use? Okay, so we're adding x to twice, which twice means what? Right, that means we're multiplying something by 2. Twice its opposite. So what is the opposite of x? Negative x. is at most 15. So what does our inequality look like? Can it be 15? Yes.
Yeah, it does not exceed.
So less than. So whatever it is, it must be less than or equal to 15. So now we solve. Because when it says find, oh, way out here. All right. So when we say find all the numbers, because the answers to most solutions, yes. Do you need to sharpen it? Yes. All right. So that's really what you have to do with word problems, is just find the little words and one at a time, find out what they mean, and then sort of create a relationship between them. All right, so let's simplify. What can we simplify 2 times negative x to? Negative 2x. So this is x minus 2x is less than or equal to 15. All right, can we simplify it a little bit more? What's your understood coefficient when you don't see a number? 1. Right? Don't forget that. So 1 minus 2 is negative 1 x. So let's make sure, I'm just going to tell you right now, make sure you have nice, neat notes of this process. So you remember that when there is no coefficient showing, it's an understood 1. So you would also see negative 1x as just negative x. So there's only 1x. So can we leave it that way? Right. We are dividing both sides.
X is greater than or equal to.
There we go. You gotta flip it. You just divided by a negative number. There we go. Oh, they're over at the gym, aren't they? All right. Can you suffer a little quieter? You just talk a little quieter for me. All right. So yeah, so because we divided by a negative 1, we must flip our inequality symbol. All right, number 13. This is our last one on here. So Tom is deciding whether to get a gym membership that costs $45 a month. So we know there's a 45 in there somewhere. If it's $10 per visit for non-members, how many times would he have to visit the gym? That's supposed to say monthly, sorry, mark through yearly and put monthly. How many times would he have to visit the gym for the monthly membership to be worth it? Yeah. So 45 is going to go on one side because he's comparing $10 per visit to 45. But what's his unknown here?
Yeah, his unknown is
how much does it cost for a monthly membership?
$45.
How much does it cost if you just go pay per visit as a non-member? So we know cost. So we know that $10, and what we're trying to figure out is how many times would he have to visit the gym for the monthly membership to be worth it? It would, but we got to figure that out because the math is not always the math is not always going to be that easy. And I can tell you that right now that on your quiz it's not quite that. It's kind of that easy, but not quite. But $10 per visit, I'll make that a V. At what point is $10 per visit more expensive than $45. That's what we're trying to figure out, right? So you divide both sides by 10, and you end up that he needs to make, well, yeah, it needs to be better than 4.5. He would make 4.5 visits to break even. Can you make half a visit to a gym? No, right? Not really. Therefore, we just immediately round up. If we're talking about doing something or being somewhere, just round it up to the next whole number. So the answer is that he would have to visit at least 5 times in 1 month for it to be worth it, which is feasible. You can see how that would attract people to a monthly membership because they figure I need to go at least more than twice a week. Even twice a week would be 8.
Once a week.
Mhm.
Nearly.
Yeah. Okay. All right. So let's look at your textbook for a minute. There's 2 in there I want us to look at, which I think we have just enough time. This Gilmer's outside the door, Victor. Yeah. If you want to join your classroom. Oh, let's see. Chapter 4, page 151. Okay, so on page 151, I want to look at number 26 and 28. Page 151. All right. So these are examples from the textbook, page 151, numbers 26 and 28. So number 26 is similar to number 12 on your review guide. It says find all the numbers such that 1/3 of the number is at most 5. Now, what this asks is for us to write an inequality and solve it, and then use a word phrase to state our answer. I just want to kind of do the first part of this. All right. So what do we know in number 20? What are we comparing in number 26? Anybody? You already have it open? So what have they given us? Okay, 1/3. Okay, so what does of stand for? What does that mean? The other one. Yeah, it's multiplication. So it's pretty much 1/3 of a number. So 1/3 times a number. Now, when you're working with fractions and you're multiplying fractions, you can write 1/3 times x as x over 3 if you wanted to. But okay, doesn't work.
It does work.
Not all the time. Is at most 5. So 1/3 x. If it's at most 5, what symbol do we use?
Yeah.
Less than or equal to, right? Because at its most, it can be 5, but it cannot be more than. So that doesn't mean it equals, but it means it must be less than or equal to. All right, so now let's solve. So we multiply both sides by 3 over 1, which is the reciprocal of 1/3. And these become 1, so you're left with x is less than or equal to 15. Which makes sense, because now we know that 15 divided by 3 is 5. And that as long as the number is less than 15, less than or equal to 15, that you'll have a true inequality. That's statement. Good. Yeah. You can do it, it just gets complicated. All right, let's do the Let's do the last one. All right, number 28, a season pass to the amusement park costs $117 and daily admission costs $39. Determine the number of trips to the park for which paying daily admission is more expensive than purchasing a season pass. 3 days, right? Okay, let's work it out. What does that look like in terms of an inequality?
Okay, so you have 117 on one side. Okay.
Uh-huh.
The other side, you just so happen to have 39x.
Okay.
Okay, and then, let me look.
So what you're asking is, at what point is 39x greater than 117? That's what we're trying to solve here. So that also, you could write it if you wanted to put your variable on the other side. You could say 39x. At what point is $39 per day more money than 117? Yes.
You just so happen to get, I'm not too positive.
3. Is it even?
It's even for.
Even 3. Well, that was easy. So 3 times or 3 visits.
Huh, I said that.
Yep, you're right.
I'm telling you, the Andrew method.
All right, now that's it. Any questions? Just about this review guide though.
Why do we still go to school?
All right.
Just the subject.
The quiz for this will be on Monday.